Divide. Write answers as mixed numbers when necessary. 9 can fit into 24 2 times. 9 times 2 is 18, but I need to get up to 24. So 18 plus 6 more would give me 24. So that's 2 wholes and 6/9 left over. Scott explores the statistical question. What is the typical number of mini tacos a student in my class got on Taco Day? He asked the students in his class how many tacos they got that day. He organizes the data set by creating the following dot plot. A. Estimate a typical number of tacos these students got. Mark your estimate with a vertical line on the dot plot. I estimate that 3 mini tacos is typical. Describe the spread. The spread is from the smallest to the biggest amount that was sampled. So we have a spread of 5 because 5 minus 0 equals 5. What is the shape? It is similar on both sides, so this is approximately symmetric. I said that 3 was the typical number of tacos. You may disagree and say 2, or maybe somewhere in the middle. In statistics, we can choose multiple ways to describe the center. One of those methods is by looking at which one has the most, but we're going to look at a different method today. Julie asks 10 of her classmates how many mini tacos they got on Taco Day. She draws the following picture to represent the data set she collected. Create a dot plot to represent this data set. The smallest amount I see is 1 taco, and the greatest amount I see is 5. Here we have 3, 3, 1, 1, 4, 4, 2, 5, 4, and 3. Scott always chooses the most common value to estimate the center of the data distribution. What would Scott choose as the center of Julie's data distribution? Scott would say 3 or 4 because both of those have 3 points on them. Do you think Scott's choice represents a typical value in Julie's data distribution? Why? I would say yes. Most of the values are around 3 or 4. If each student got the same number of tacos, how many tacos would each student have? Draw a picture and explain how you got your answer. I'm going to start by placing a dot for each taco on the plate that they had. So Jada had 3, Riley had 3, Toby had 1, Lacey had 1, Lisa had 4, Tyler had 4, Kayla had 2, Kelly had 5, Ryan had 4, and Noah had 3. So if I were to share these, if I had one, I could borrow one from the people who had more so that they have the same amount. Then everybody has 3. So then they would each have 3 tacos. Do you think this value is a better measure of the center than Scott's value? Why? I think it does. It considers all of the people, including those who had more or less than 3 to 4 tacos. Logan is curious about how many pencils a 6th grader carries. He asks 5 6th graders how many pencils they have in their backpack that day. Logan displays the data set in the following tape diagram and dot plot. So you can see here there are 2 students with 2, 1 student with 1, 1 student with 4, and 1 student with 6. Suppose all of the students equally share their pencils. Make a tape diagram and a dot plot that shows each student with an equal share of pencils. So that is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 pencils to be split up amongst 5 students. So then each student should get 3 pencils. There are 5 students that all have 3 pencils. If all students equally share the pencils, how many pencils will each student have? They will each have 3 pencils. Then it says, what is the measure of center that represents equal shares called? This equal share or fair share method is called the mean. You may also hear to it referred to as the average. Sasha notices that the school janitor carries a lot of keys. She wonders how many keys adults in her school usually carry. She surveys adults at her school and displays her data set in the following dot plot. Find the mean. To find the mean, we're going to put all the keys together and then share them equally amongst the adults. So this adult has 1 key. Then we have 3 adults with 2 keys, 3 adults with 6 keys, and 1 adult with 7 keys. When we add all those together, that's 3, 4, 5, 6, 7, plus 6 makes 13, 19, 25, and 25 plus 7 is 32 keys for all of the adults. But there are 1, 2, 3, 4, 5, 6, 7, 8 adults. So 32 keys shared amongst 8 adults is 4 keys per adult. And then we need to interpret it, the mean number of keys in terms of equal shares. If all 8 adults had the same amount of keys, they would each have 4 keys. Find the mean of the data distribution and use it to answer Scott's statistical question from problem 1. So we have 2 zeros, 4 ones, 1, 2, 3, 4, 5, 6, 7, 8 twos, 9 threes, 1, 2, 3, 4, 5 fours, and 2 fives. So we need to add all the tacos together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 18, 20, 23, 26, 29, 32, 35, 38, 41, 44, 47, 51, 55, 59, 63, 67, plus 10 is 77 tacos. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30 people, 30 sixth graders. Now that's in between 2 and 3 tacos. So you could round to say that the mean is about 3 tacos. So the strategy to find the mean, we add up all of the values and then we divide by how many values there are.